Again, welcome to Research Methods in Computers and Society. This is CS 312 class. This is our first lectures, and in these lectures, we're going to cover the chapter 1 of the course textbook. And our main topic is the purpose of research and overview of research process. So in these lectures, we're going to discuss what is a research, the definition of a research, and 3 different types of research, and also research process. So learning objective, again, we're going to describe the scientific research and its purpose in furthering knowledge. Also summarize 2 theories of knowledge, the falsifiability and the scientific revolution. Also compare and contrast qualitative, quantitative, and mixed methods. And the last will be explain the importance of ethics and objectivity in research. So yeah, we start with learning about the word non-scientifically. Again, according to our course textbook, we have 3 types of way we can gain knowledge. The first one was the traditional knowledge, or we use the term inherited knowledge. This is a knowledge that normally we inherit from our parents or from our culture, the value of our traditions. So an example would be there are some society that kids have to obey their headers or greet their headers in a different way. And we go to some society again, it's a different way. And how to cook. So again, here in general, traditional knowledge is culture values. We derive that from our parents and also our environment. So it's an inherited knowledge. Another knowledge is the knowledge from authority. So the good example the textbook gave to us is taking an antibiotic will cure my illness. So here our authority will be the medical doctor. So a medical doctor may prescribe a specific medicine to us that by taking that medicine, disease A will get healed. Now, after we know it the first time, again, next time we know when we have the same problem, we know what medicine to take. So this knowledge normally will come from authority, not only in medical field, but also it can be in the engineering field or even judicial system. And there are some rules and laws we have to follow in society. And we don't learn that from our parents. Actually, we learn from the authorities who enforce the laws. So here we say authority figures can include the parents, teachers, and professional figures. Example would be medical doctor, engineers, etc. Teachers is a very good example. Again, a teacher in elementary school or high school may have a specific rules that students have to follow. When maybe a teacher is giving lectures, students are not allowed to talk, or students are not allowed to go outside, or they are not allowed to eat in a classroom. This again, knowledge from authorities. And the last one is the experiential knowledge. This is a knowledge that we gain it ourselves. So example given here, touching hot pot will cause a burn. This is not a culture. This is not from authority, but I know that when I walk on a fire, the fire will burn me. Or when I touch a fire, the fire will burn me. And also, this is knowledge that we gain from experience in life. So there are so many examples, even in marriage, having a friend. Maybe I had a friend first time, things didn't go well due to some few things. So I learned from that. Next time when I'm going to make friends, I make sure those things that make our friendship bad, I will avoid it. This is again experiential learning from experience. So again, those are the 3 types of learning: traditional knowledge, knowledge from authority, and experiential knowledge. Next, we're going to define what is a research. Here we say research is a systematical process based on scientific method. So again, research is a scientific method and it's a systematical process This will facilitate the identification of a relationship and determination of differences in order to answer a question. So most of the time when we are doing research, most likely we may have two or more variables and we want to determine if one variable causes the next variable. That means we have independent and dependent variable. Or we may have two variables. We want to know if there's any relationship between the two. If the first variable value increase, will the second variable value also increase? So a research normally is based on, that's what we're saying here, identification of relationships and determination. I may have 5, 6, any amount of variables, and I want to find if there's any relationship between the variables. By increasing and decreasing the value, will it affect the dependent variable to increase or decrease? Determination, we want to know if environment A causes disease A. So that will be determined. Then also there are 4 keys to scientific method. First, we have to generate our hypothesis. Then we have our observation. In statistics, observation means data of each person or each entity. So it can be observation or data collection. So when we have our data, we can test our hypothesis. Generating hypothesis, we know we have 2 types. The claim will be the null hypothesis, and counter claim will be the alternative hypothesis. So we test our hypothesis using different types of statistic testing methods, such as z-test using the standard normal table, or t-test using the t distribution table, or ANOVA using the f distribution table. Then next we have our conclusion. So after testing, we may have either to reject the HO, which is the null hypothesis, or to accept HO. So there we make our decision and we have our conclusion and compare results from previous work. So these are the 4 keys to scientific method: generate a hypothesis, observation or data collection, testing the hypothesis, conclusion, and compare the result from previous work. So this is our research process. And this will be used a lot again in our thesis or dissertation in the future if we may decide to go to a graduate school. So for example, first we need to have a problem. In order to do a research, the goal of doing research is to solve some problem. Finding a relationship between 2 attributes, or trying to find out if attribute A causes attribute B. So we have to state our problem. So first, statement of problem, specify and justify the problem. Then we generate our hypothesis. So formulate the research question, practice testable statement, questions of the research problem, which will be our hypothesis. Then after that, we want to have some background knowledge of what we are doing. And always it's very important that we have a review of literature. Review of literature would normally help us to validate our research. Our research may be based on the previous research or some previous phenomena. So again, first step, statement of problem. Second step, state your hypothesis. Our hypothesis will be our questions. Then the next step, review of literature. Again, review of literature is collection and also summary of prior relevant studies. Then after that, we do our measurements. Here we say operationalization of concept. So we can use any tool that is available or that is required for the field. We can use it again to determine our measurements. Then we do our sample collections. Here we say group of people from which data can be collected. So when we collect our sample, we measure the sample by doing data analysis. So we do statistics techniques to summarize or interpret the findings. So we do our data analysis. So those are the steps, and now we go through each of them. An example. So as we said earlier, the first thing is statement of the problem. Now here we have 4 examples. The first one says the proportion of obese American youth is increasing at an alarming rate. So this will be research that I want to do. Want to find out if obese among American youth is increasing in a very high alarming rate or exponentially. Now, I may have another problem. An unusual high number of young men with rare opportunistic infections are being seen in New York and California clinics. This related to the early 1980s when AIDS, HIV was discovered, because they found out that disease like pneumonia that normally old people in their 70s, 80s get it and most likely die of it. Now we have a young man, very young age, very strong when you look outwardly, but they have this pneumonia. So maybe there may be a secondary or some factor that causes it. And this is what led to, again, discovery of AIDS, HIV in early 1980. Most of these infections happen in New York and also California clinics. And actually the first HIV or AIDS patient was from San Francisco, who was diagnosed. The first patient diagnosed in US for AIDS or HIV was from, again, California and San Francisco. So another example here, children in the rural areas of China have elevated blood lead levels. So this can be a statement of a problem. Then we can state our HO and HA. Also, mine workers in sub-Saharan Africa have a higher than expected incidency of tuberculosis. So now, generating a hypothesis or formulating a research question. Now, based on our question and statement of a problem, we can generate a question from it. So we can see an example. We quite remember our statement is the American youth are more obese now than previously. So this is just, again, a statement of problem. But I can look at it and make a question out of it. So here, for example, we say an increasing prevalence of electronic entertainment contributes to the increase in obesity among American youth. Also, what do the young men with the rare infection have in common with one another? So we say there are some rare men, very young, very strong, but they all have pneumonia. Now, what they have in common? Yeah, we want to do, again, a hypothesis testing. But that's our question that we are stating here. Now, what are the potential environment causes of lead poisoning among Chinese children? We state our problem that there are increasing lead poisoning in China among children. Also, what are the potential environmental causes of lead poisoning among Chinese children? Then occupational lung irritation among minors in Africa contribute to the risk of tuberculosis. Because our question was, the statement of problem was that we have in sub-Sahara, the minors have high tuberculosis than others. So the question here will be, occupational lung irritation among minors in Africa contribute to the risk of tuberculosis. So next we move to the reviewing the relevant studies information. This is literature review. Here we say participating in the scientific method. It will help to refine the hypothesis or research question. Also, it will suggest specific study design choices. Indicates what will be new to the current knowledge. Now, the next step we said was collecting data. This is where we are going to collect our sample and we have to analyze it, then we come up with our decision. So collecting data, first we need to select the subjects. It can be an individual people, or it can be a group of people, or it can be any entity. Then we publish research results from meta-analysis. Now, when we select our subject, the next step is to measure the construct. We may have a survey questions, or another can be the lab result or effect size. So after we collect the data and we get everything straight up, the next is to analyze the data. So preparing data for analysis. And based on the type of question we want to, again, research, and the analysis of the data, we may end up using different algorithms. So here we say specifically testing the hypothesis or answering the research question. Particular method of an analysis depends on, again, the research question type, the study design, type of subject, and level of measurement of construct. Now, next, we are going to report our results. After we analyze our data, we have the results, but we don't want to keep the results, we're going to report it. So we can report results in many avenues or many ways. For example, a research report, you can report it maybe in professional journal, etc. Now, if I'm doing thesis or capstone and dissertation, then I can report it to the supervisor for the thesis or dissertation. We can also have the peer-reviewed journal article, presentation, and poster. Results should be disseminated in some manner so that they can contribute to the scientific method. Next is the scientific knowledge. We know in scientific knowledge, trustworthy is very important. So trustworthy, and also scientific knowledge is based on research studies. Also, it can be informed or driven by tradition, authority, and experience. So scientific knowledge helps us understand reality. Here we say, why participate in scientific knowledge generation? Why participate in scientific knowledge generation? Here first we say research can be fun, especially if we are doing research on a topic that is your specialty. It's a topic that you enjoy, you love teaching, then it will be fun for doing that research. Also, it can inform your career of choices and develop your portfolio of skills. And also it can make you an educated consumer. So theories of knowledge. Here we say a theory is a conceptual framework. Theory is a conceptual framework, and theories explain how knowledge is generated. Also, two widely accepted theories are the Karl-Popper's falsifiability and Thomas Kuhn's structure of scientific knowledge. So Karl-Popper's falsifiability, saying that again we may generate a theory or a rule from anywhere data set or knowledge-based system. Now, when we generate this rule, it's to be true until we prove it false. So after a year, 2 years, and we can prove that the rule is false, then we're going to abandon it, then move to the next stage. In that process, we have gained knowledge that the rule instead of true is false. So again, we may go to all the two accepted theories. So we start with the Karl-Popper's falsifiability. This happened in the 20th century scientific philosopher, and he argued that we believe a theory to be true until we prove it not to be true. Now, when we falsify this theory, that will increase or amplify our knowledge to the theory and advance and build a new knowledge. So PS1, we say problems that interest us. TT1 is tentative theory about the problem, and error of elimination, new problem that interests us. So here we know many scientists preoccupy themselves with a normal science. So a normal science can be functions on which it is already known, and also rely on paradigms and unchangeable pattern that we use repeatedly. Also, is the normal sense is disputed when we encounter anomalies, things that do not fit into our paradigms. And when these anomalies accumulated, we have problem or we have crisis. And a crisis can lead to a revolution and a paradigm shift again. So now let's go through the research method. As we said earlier, there are three types of research method. We have the qualitative, quantitative, and mixed. Mixed method means we are using both qualitative and quantitative together. Now, choosing the type of research we want to do depends on the type of data we have. And also, we have to, again, understand the difference between the two, actually between all the three. Again, mix is not really important because qualitative is by itself qualitative. Quantitative is by itself quantitative. Mixed method means both qualitative and quantitative together. So we say combination of qualitative and quantitative research methods. Quantitative research method will be based on formula analysis of data. It mostly will be based on value. That's why it's called quantitative. We can find a mean media mode again to analyze numerical informations. But qualitative, we deal with the nominal data. So the analysis will be based on ranking or the mode. So here we say qualitative research method, analysis of narratives in the form of words, text, illustration, videos, and other non-numerical formats. As I said earlier, to choose which research, it will depend on the type of data. Qualitative data are mostly nominal, very difficult to do arithmetic operation. Then quantitative data are again quantitative. Then, as we said earlier, mixed method means combination of qualitative and quantitative research method. So we start with the qualitative research method. Qualitative research method, in a short way, I would say it always have an open-end questions. So our questions are not logical that is true or false. So doing qualitative research, one of the goals is trying to gain insight of whatever you are researching and also to get more in depth of it. And often qualitative research is based on inductive reasoning. So an example here can be contemplative, and also it can immerse themselves, attentive to details, determined, committed, and also creative. Qualitative may ask a question, for example, how the word phenomena works. It's kind of like an open question. If it's quantitative, I will try to find a solution. I'm going to collect data on the phenomena of the world, and I'm going to analyze it to see if I can come with a result. So we say qualitative research are contemplative, immersive themselves, attention to detail, determined, committed, and creative. So again, qualitative research is based on inductive reasoning. So we get the observation first, understand of a topic or problem, then the creation of new theories of the science. With quantitative, again, is based on analysis of a value, a real data. So this will be a numerical notation or numerical values. So it requires specificity and pre-calculation. And also it often utilizes structured questionnaires or surveys, often based on deductive reasoning. So quantitative researchers can be good at organizing, categorizing, and calculating, because here we need to again analyze the data. Then we need to be specific. Now with quantitative, the reasoning is deductive. So theories of science, example, idea or concept, test of this idea or concept. And the last one is the mixed method. So mixed method, we say the combination of qualitative and also quantitative. So mixed method are increasingly utilized and appreciated. Many benefit to combining qualitative and quantitative research. Also, it allows the collection of vast amount of information and details in depth and promote more confidence in our conclusion. So next we start with the ethics. Ethics is very, very important in the research process because when we are doing research and we are using a subject, most likely, again, first we know ethics are a group of morals and values that govern our behaviors and decisions. So when we are doing research and there's again a group of people, maybe we may take a subject, we may take a data, or we may take a sample. We have to be concerned. The ethics here in researching means concerning the welfare of the subject we are studying in the research process or the experiment. So moral issue can be the welfare of the subject. Are we giving a bribe and maybe too much amount of money or finance that can influence a decision? So yeah, we say ethics are a group of moral against morals or values. So by doing the right thing, then you are going along with the ethics. So here we say, how can we protect research participants? As I said, this will be a research ethics question. The welfare of the participants are very important. The risks and benefits. Provide people with accurate information about the risk and the benefit of participating in a study. So here we say example will be risk associated with participating in a drug study. Confidentiality also, we have to address that in the research ethics. We may collect data. For example, there are so many biological and clinical data online. But when you go to this data set, most likely you won't see the names of the patients. Maybe you may see a patient ID and whatever the information is about what we are trying to study. So we protect the identity and data of your participants. And also coercion, do not coerce your to take part in the research. So yeah, maybe we're trying to give a gift to the participants so that they can participate in the research. And also conflict of interest. We should acknowledge and disclose the conflict of interest to participants and when presenting research findings. Here we discuss about the human subject training. Here we say all researchers working with human participants must complete a free online training on ethics and access this at the following link given to it. So here again is a human subject training. All researchers working with human participants must complete a free online training on ethics. So example of evaluation of ethics, we know that Tuskegee syphilis study. Here we are trying to study subjects if they have a syphilis, but we didn't even tell them. Maybe we inject them with syphilis and see their reaction in their body. We didn't tell them. So this is evaluation of ethics. Ethics in research process is considered 100% welfare of the research participants. As another example, intent was to study the effect of syphilis on the human body. Now, 600 African American men were recruited to participate, and the study intent was not disclosed to the men, so they didn't tell them what kind of studies they are doing. An effective treatment as the penicillin was discovered in 1942. However, the men were not treated. So this is another breaking the ethics. This is on ethics. You have given participants a disease. Now you have the vaccine for the disease. You didn't give them. So research bias, which we say objectivity, or the ability to perceive something from different angles without personal experience or judgment, is very critical to science. So we need to be very objective. Being objective requires recognizing your own biases and also minimizing your biases. It can be ethic bias, data collection bias. Maybe data is not well represented. So we always have to do our best to remove. So research bias can be subjective thinking. This is based on personal emotions, experience, and prejudice. Now, selective observation, it can be the conscious or unconscious focus on what interests us or failure to notice things that contradict our theory. Overgeneralization is using a small number of cases to draw conclusion about the entire population. So again, subjective can be based on emotions or experience of the participants or prejudices. So for example, we have a selective observation, which will focus on specific occurrence or specific group of operation. So this example give it to us. We have a subjective thinking. I really like you. And we say she's so nice. Yeah, she needs something from me. She's trying to make friends. She like to give gifts. This will be objective thinking. Again, this will be the conclusion of our chapter 1 lectures from the course textbook. Again, these lectures we discuss about what is a research, the ethics involved, the research process, and 3 different types of research methods. So again, wish everybody the best. Again, before we start the course, again, review the syllabus, and I have a video lectures also on the syllabus. Thank you. See you in lecture number 2, which will be our chapter 2 of the course textbook.